Okay, here is the second part of the quiz one review. For this part, these problems could show up in the calculator part of the test. But remember that your quiz is all calculator allowed, even though your test is part no calculator, part calculator. I just want to start the process now of helping you understand what's going to be what. Okay, so for number one, we have to take the fourth root, and we're taking the fourth root. That means we need to look for groups of 5. And we know, so we're going to have to make a factor tree. We know that's not divisible by 2, but certainly seems like it should be divisible by 5. So when I do that, I get 5 and 375. Divide by 5, I get 5 and 75, 5 and 15, and then 5 and 3. Sure, there's other ways to break them up, but your numbers at the end should be the same. So here is a group of 5, so that goes outside. The 3 goes on the radical, the 4 goes on my shelf. Now we have to deal with the variables. Well, how many groups of 4 are in 9? Well, there's 2 groups of 4, and that's 8. So there's 1 left over. And how many groups of 4 and 12? Well, there's 3. Didn't leave good space in there, but there's my answer. Okay, let's try this again on number 2. On number 2, we're looking for the fifth root. So now we got to simplify that. Well, I'm going to try dividing it by 2 to start. That works. I get 2 and 729. That's not even, but I can try 3. So I get 3 and 243. Let's see if 3 works again. Oh, it does, and I get 3 and 81. 81 is nice because I get 9 and 9 and then a bunch of 3s. But this time I'm looking for groups of 5. So here's a group of 5. So when I'm writing my answer, I've got my 3 that goes outside from the group. And then inside, I not only have 2, but a 3 as well. And then I've got the 5 on my shelf. For the variables, in 15, there are 3 groups of 5. And for the H's, there are 1 group of 5, and then 1 group of 5 is just 5. 8 minus 5 is 3, so there's 3 left over. But I don't want to leave my answer like that. I can simplify that more. So my final answer is 3g cubed h, fifth root of 2 times 3 is 6, h cubed, and that's my final answer. Okay, let's take a look at number 3. On number 3, when the 2 parentheses are touching, that's multiplying. So the numbers I'm going to multiply the same way I've always multiplied them. 3 times 4 is 12. With the variables, I need to add the exponents, and I keep the base the same. So I have 1/2 plus 2/3. I need common denominators, so that would be 6. Multiply this one by 2, so we get 4. So all together we get 7, 6. Now remember, the 12, we don't need to change because its exponent's an invisible positive 1. But the x we need to rewrite because we can't have a fractional exponent. So I get the 12, the x goes underneath, the 6 goes on the shelf, and the 7 is my exponent. Now, oftentimes you're going to be done here, but sometimes it goes further and you've got to check. So the 6th root means that you're looking for groups of 6. So we have to ask ourselves if there's a group of 6 and 7, and there is. So we're going to take that x and write it outside, and then that accounts for 6 of the x's. So that means there's 1 more left over, and that is my final answer. Okay, number 4 is kind of a tricky problem, and it's definitely the hardest one on here. So if we can get through understanding this, there's one similar on the quiz review, and I think you'll be okay. It's not quite as difficult on the quiz review. Again, we've got multiplication. The problem is, and we know multiplication because of the 2 parentheses, the problem is we have that 2 on the second one, that exponent. And if you think about the order of operations, exponents comes before multiplication and division. So we need to deal with the power to power before we do the multiplication. So on this one, 2b to the 1/2, that can stay. But over here, I've got to distribute that exponent. We do a power to a power, we multiply. Well, right now, 3 has an invisible 1. So if I take 1 times 2, I get 2. So that gives me 3 to the second power. But 3 to the second power is 9. And for this problem, it's going to be way easier to work with it as 9 than 3 squared. Okay, now we have to take 2 times 1/2. Well, half of 2 is just 1. That's easy. And now we have to take 2 times 1/3. So 1/3 times 2, multiply straight across the top, and we get 2/3. Now the problem's exactly like the one before it. So we're going to multiply. And I knew that because the two parentheses were touching. So 2 times 9 is 18. With the b's, I'm going to add the exponent. So I have 1/2 plus the invisible 1. Well, 1 is 2/2. So 2/2 plus 1/2 would just be 3/2. If you can't do that in your head, then by all means write it out. With the c's, there's our answer there. So now we've got it all simplified. We just need to write it in the correct form. 18, we don't need to change because it doesn't have a fractional exponent. But the b's, we need to rewrite. 2 goes on the shelf, 3 is the exponent. The c's, we need to rewrite. 3 goes on the shelf, 2 is the exponent. Now, again, a lot of times we're good after you rewrite it, but every once in a while it simplifies more, so we need to check. If we look at the c's, they're looking for groups of 3. Well, do we have any groups of 3 and 2? No, we can't make a group of 3 with just 2. So that one can't simplify. But if we look at the b's, we're looking for groups of 2. And we do have a group of 2 and 3. So we got to simplify the b's further. So I can take out one group of 2, and that gives me 1 left over. Now you could write the 2 on the shelf, but remember the square root, the 2 on the shelf is not necessary. Over here, though, we want to write it. Now, some of the other problems look complicated, but nothing's nearly as complicated as that one. Okay, number 5 wants us to take the cube root, and everything's under the radical. So we want to simplify everything that we can first before we take the cube root. Okay, so under there, I've got 192 and 3. Well, 192 divided by 3 is 64. And because 192 is on the top and it's bigger, then 64 is going to go on the top. With the, oh, I forgot my cube root here. With the x's, there's 7 on top and 1 on the bottom. So when I cancel, I get 6 on the top. The y's have nothing to simplify with, so I just have y to the 9th. The cube root of 64 is a perfect cube. And if you're not sure, because this is on the calculator section, you can check that into your calculator. You go to the math button. Option 4 gives you the cube root. Option 5 gives you taking the root or any root you want. So option 4 is probably the most efficient on this one. If you take the cube root of 64, you get 4. For the cube root, we're looking for groups of 3. So there are 2 groups of 3 and 6. Whoops, I wrote the wrong number. And there are 3 groups of 3 and 9. And there's our answer. Number 6, when we have parentheses, we want to see if we can simplify anything inside the parentheses that we can before we try and do the power to a power. But the c's and d's won't reduce, and 16 and 81, they can't reduce at all either. So I'm just going to distribute the 1/2. So I have 16 to the 1/2. With the c, 1/2 times 14 would just be 7, because half of 14 is 7. Then I have 81 to the 1/2, and then half of 18 would just be 9. But we can simplify those numbers because we know anything to the 1/2 power is the square root. So that's really the square root of 16, which is 4. So that's 4c to the 7th. And that's really the square root of 81, which is 9d to the 9th. And there's my answer. Okay, if we keep going on the back, over here, we've got a bunch of radicals multiplied together. And if the same number is on the shelf of all the radicals, then we can merge them into 1 and then simplify. So I'm going to merge them into 1. So I've got the cube root of the number 16 times 4 is 64. And with the x's, when we multiply, we add the exponent. So 2 plus 2 is 4, times 5 is 9. So we get x to the 9th. So now we simplify. The cube root of 64 is 4. And the cube root of 9, well, there's 3 groups of 3 and 9. So I have x to the 3rd. Done. Okay, number 8, to write this in reduced radical form, we had to multiply top and bottom by the conjugate of the bottom. So the conjugate of 3 plus the square root of 2 is 3 minus the square root of 2. So on the top, we need to distribute, and that gives us 36 minus 12 square root 2. On the bottom, because it's the conjugate, we can work smarter, not harder, and multiply just the first and last. So 3 times 3 is 9. A negative times a positive is a negative. The square root of 2 times square root of 2 is the square root of 4, which is 2. Now, it may be tempting to reduce the 36 and 9 or the 12 and the 2, but you can't because they're combine or connected with plus and minus signs. But what I can do is I can simplify the denominator. 9 minus 2 is 7. Now we're going to ignore this radical 2 for a second and ask ourselves if there's any number that goes into 36, 12, and 7. And the answer is no. No, there is not. So this is my final answer. Okay, number 9, when we're multiplying, you can multiply anything you want. So you can multiply the numbers that are outside. 6 times 5 is 30. And the numbers that are inside, 2 times 10 is 20. But now we have to see if this simplifies. That would be 2 and 10 and 2 and 5. So the 30 is outside. The 2 can now come outside and the 5 is underneath. So my final answer is 60 square root 5. Number 10 is adding and subtracting. You can only add and subtract if they're like terms. But on number 10, they're not like terms the way they're written, so we need to reduce the radical. So 12 is 3 and 4 and 2 and 2. So that negative 8 comes out. The 2 can also be pulled out, and the 3 is left over. So we're left with negative 16 square root 3. On the other one, 27 would be 3 and 9 and 3 and 3. So the 6 is already out. The 3 can get pulled out, and then this 3 is left over underneath. So it gives me 18 square root 3. Now that the radicals match, now I can add them. Negative 16 and 18 would be 2 square root 3. And there's our answer. Number 11, when you square a radical, you're going to square each term. So 7 squared is 49. The square root of 6 squared would be the square root of 36, which is just 6. When you square a radical, it cancels it. Okay, let me grab our calculator. Now we need to take 49 times 6, which would be 294. Okay, on the last one. Now let's go back to number 8. On number 8, when we multiply the bottom, we did the conjugate. So the conjugate has where the whole numbers match, the radicals match, but one's a plus and one's a minus. So when it was the conjugate, we could do the shortcut. But in here, the radicals match, the constants do not, and then one's a plus and one's a minus, or not, and we don't have opposite signs. So it's definitely not a conjugate. So we can't take the shortcut. We got to multiply everything out. So 4 square root 5 times 4 square root 5 would be 16, because 4 times 4 is 16. Radical 5 times radical 5 is 5. Over here, 4 square root 5 times negative 8 would be negative 32 square root 5. Over here, negative 7 times 4 is negative 28 square root 5. And then over here, negative 7 times negative 8 is positive 56. Now we do need to combine like terms, but before we do this, 16 times 5 is 80. So now let's combine like terms. 80 and 56 is 136. Negative 32 and negative 28 gives us negative 60 square root 5. And that is the end of the second part of the notes.